Here we are with some instruction on rational expressions. Now let's review for a minute what rational means. It means we have a ratio of things going on. Back with numbers, that meant fractions. And so fractions, if you recall, like 15 over 21. Well, that's what we're going to do here. We're going to have some rational expressions, except they're going to be, instead of fractions, they're going to have polynomials like 3x over 7x. And the first thing we did with them was we simplified. So that's the first thing we're going to do is simplify. Now we're going to look at what happened with fractions, and maybe you remember. You might think, hey, I remember those. Yeah, we simplified. Those things were each multiples of 3, so we divided by 3 and divided by 3, and we ended up with, hey, that equals 5/7. That's pretty good, not bad. Yeah, that's exactly what happened, but we're going to do it in just a little bit different way so you can kind of see exactly what that means. We actually, and this is going to be the key for everything, you remember with polynomials, you learned how to factor. And factoring is like splitting a number open to see what it's made of. Here, if we did a little factor tree of 15, this becomes 3 times 5. And down here, 21 became 3 times 7. Now, if you notice, this divide sign right here and this times sign, they undo each other. And that's what, well, 3 over 3, that is a great big 1. And that's actually what canceling means. When we say canceled, the 3's canceled, actually means 3 divided by 3 was 1 and left us 5 over 7. Well, the same thing happens over here. Even though you may not be able to identify exactly what this is, or you don't know what this is, there are variables, you can see, oh, that's timesing an x. And this is division. So anything on the top and anything on the bottom can divide to 1, or, as we'll see or call later, it's canceling. So we get to 3/7. So let's see if that works with a little bit different number, but kind of the same. If we have something like 3x plus 12 on the top and 7x plus 28 on the bottom, well, word of caution really quick. You may not take these x's and cancel them. That's bad news. We got to talk about that. You see this right here? That's a plus sign. Now, what does a divide sign undo? It undoes a times sign, not a plus sign. Get out of there. Don't do that. It's bad news. So you may only do things when they are multiplying. That's the only way you can actually undo them. So in order to make those work, you need to factor this. Can you factor the top? Yeah, you can take out a greatest common factor. You get 3x plus 4 with parentheses around it like that over 7x plus 4. Oh, now look at that. You see, this is a times sign in between there. They're next to each other. That means the x plus 4 over x plus 4 is a 1. And this one reduces down to 3/7 as well. Let's try another one that maybe you don't know yet. This is x squared minus 4 over x squared plus 3x minus 10. Now, a word of caution again. These x squareds, you may not cancel those guys. This x squared is being subtracted, it has 4 subtracted from it. You can't undo division with subtraction. Get that off of there. Don't even think about that. In order for it to go, you must factor it. So let's do this one. This guy, factor the top. It is x plus 2 times x minus 2. And the bottom, this one, there are 3 terms, leading coefficients 1. So we know it's going to be an x and an x. So now we have to think, what times is to a negative 10? Well, it's a 1 and a 10 and a 2 and a 5 that adds to a positive 3. It's a positive 5 and a negative 2. Oh, and look what we have there. Oh, look at that pretty little thing right there. So, simplifying, this is how we do it. Big deal. Factor it. Once you get into factored form, things that are multiplying can cancel or divide to 1, and you're left with everything that's left over. Woohoo! There you go. There's simplification right there. Now, very close to it is going to be multiplication. There we go. So let's try it with numbers. Let's go back and see what we did with numbers. 2/3 times 3/5. Now if we do this the long way, we've got 2 times 3 is 6, 3 times 5 is 15, and then we reduce it and we're like, oh, what do we do? Oh yeah, we got to divide by 3, and then that equals 2/5. Now I'm going to do this in slow motion again, and so you can see what's going on. We took 2 times 3 was 6. Now if we broke this up and did the factor tree, 6 would be a 2 times a 3. Really? Look at that right there. And the 15 would be a 3 times a 5. Oh, look, it's right there. And then you would cancel, divide, so they're equal to 1, and you get 2/5. Okay, so now that I did that painfully slow, let's talk about this. When you go clear back, I'm going to go and undo that whole thing. When you are in multiplication, you really are just doing the top times the top and the bottom times the bottom, which means this is really all one fraction with multiplication going on the top and the bottom. There's no reason to times things together if you're going to end up factoring it. Can you see how this might work with polynomials? Anyway, so that'll happen to 2/5. Let's try it with a couple of things like this on polynomials. Let's write one out. 2 over x minus 5 times x minus 5 over x plus 8. It's going to ask you to multiply these and then simplify. Well, you could take 2 into the x and 2 into the 5 and then FOIL or super distribute these guys down here. But why would you? Because simplification is you're going to have to factor it. So don't do that. Just draw the line straight across and say we're going to take 2 times that and x minus 5 times x plus 8. Can you see what'll cancel? Of course you can. And you get 2 over x plus 8. So multiplication is really, you take the top times the top and the bottom times the bottom, and then you, ta-da, factor. And that's important. So let's try another one. A number where that didn't work so well. Let's try it. 6/7 times 14/18. Now you might be able to see that this, you could do 6 times 14 and get a great big number over here, and 7 times 18 get a great big number, and then we try to factor them. Why don't we do this right away? 14 is 2 times 7. 6 is 2 times 3. 18 is 2 times 9, which is 3 times 3. And 7, well, it's just 7. But can you see things that'll cancel if you multiply the top and the top and the bottom and the bottom? And now we're like, oh, dude, 7 can cancel, divide to 1 with that 7, and that 2 can cancel with that 2, and that 3 can cancel with that 3, and we're left with a 2 on the top and a 3 on the bottom. Man, Shazam! That's slick. Should have known that years ago. Let's see what it looks like with polynomials. Here's one. X squared plus 4x minus 21 all over x plus 3. Now again, can the x cancel the 3 with the 21? No, that's addition. You'd have to cancel the entire x plus 3 with something on the top. Timesing it by x squared plus 8x minus plus 15 all over x squared minus 49. Now you will get a problem like this green one down here, and you'll be expected to simplify, multiply it, simplify it. So if you just take and make it one great big thing and then factor these, then you just have to slash and burn the top with the top, the bottom with the bottom. All right, so we're multiplying top to top here, but let's factor this. We have x. Let me see, what times is to a negative 21 and positive 4? That looks like a positive 7 and a minus 3. Ooh, that's so close. That almost cancels with itself there, but it doesn't. Let's try this one. What times is to, we have x and an x, what times is to 15 and adds to a positive 8? That's a plus 3 and a plus 5. Oh, we're getting closer. Look at that. Those x plus 3s will cancel. And again, this just multiplies with this guy. Ooh, but what does that factor to? That factors to, oh, that's a difference of squares. xx, that's a plus 7 and a minus 7. All right, let's start slashing and burning. What can we get rid of now? We can get rid of, it looks like, that plus 7 and that plus 7, that x plus 3 and x plus 3. So what are we left with? Looks like that's going to equal x minus 3 times x plus 5 over x minus 7. And you could leave the answer just like this, or you could multiply those out, and that should work. All right, let's clear this off and let's do a division problem. That's the only thing we've got left. Good, we're at division. And do you remember how to divide? Let's see if we can remind ourselves. 13 over 15 divided by 2 over 35. Let's see if we remember. Yeah, division is really, you write it like this, times this reciprocal. Every division problem gets written as a multiplication problem, which we already did, but we'll continue this out to make sure we get it right and that you remember how to do that. But really, you multiply by the reciprocal, which means since you're multiplying, you're going to factor. So factoring is a major part of this entire section. So let's do this one. 35 is 5 times 7. 15 is 5 times 3. 13 doesn't go down any further. 2 doesn't go down any further. 5s will cancel. So we got 13 times 7 is 91. 3 times 2 is 6. And that's your answer. That's how we did it with fractions back in the good old days. Now let's do it with rational expressions with polynomials. X squared plus 7 over, I don't know, 2x squared plus 11x plus 12 divided by x over 2x squared plus x minus 3. Boy, that looks not too pleasant. Okay, so again, we're going to rewrite it just like this, but with a multiplication symbol. So let's just undo that. Well, let's write it. So it's really going to be timesing 2x squared plus x minus 3 over x. And let's rewrite this guy. There we go. Okay, there we got him. Now, we have to factor. We're in multiplication. This guy, he's prime. That's x squared plus 7. That's not going anywhere. Let's see what this guy does. Leading coefficient 2, so we're going to have to factor this. 2 times 12 is 24. That's possible 1 and 24, 2 and 12, 3 and 8. Oh, that'll add to 11, or 4 and 6. So 3 and 8, this is 2x squared plus 3x plus 8x plus 12. Out of this half, I can pull an x and get a 2x plus a 3. And out of this guy, I can take a 4, gives me a 2x plus a 3. And I get 2x plus 3 times x plus 4. Whew. That's what this bottom guy is. This guy I'm going to have to do off to the side a little bit. 2 times negative 3, let's put it up here, is negative 6. You can have a 1 and a 6, or a 2 and a 3. And it looks like a positive 3 and a negative 2 will get that one. So we actually get 2x squared minus 2x plus 3x minus 3. Factor something out of there and you get a 2x times x minus 1. And plus 3 and an x minus 1. So this guy is really, let's write it out up here, with 2x plus 3 and x minus 1. Alrighty, do we see anything that can cancel now? Yeah, we do. Let's cancel it out. This guy can go with that guy. And that's it? We got gypped. That's all we got. X squared plus 7 times x minus 1 over x plus 4 is left here, and times x. So you could multiply all those out and get x squared plus 4x on the bottom. I don't know if that'll help to times it all together. It might, but it doesn't look like it's really getting a lot. X cubed minus x squared plus 7x minus 7. I suppose you could leave it like that. Alrighty, and there's division. So we have simplification, multiplication, and division of rational expressions. And again, that rational comes from the word ratio, which means fractions, polynomials with fractions.